Thank you very much, Alex. And might I say you're doing a fantastic job hosting this. So yes, let's talk about building Neo4j Ops Manager and the lessons we've learned from using all of our internal or tools that are available in the Neo4j ecosystem. As you've heard, my name is Sascha. I am a software engineer at Neo. Before I joined the Ops Manager team, I had the privilege of working in the Cipher team as well. And that's all you need to know for right now. So let's talk a bit about Ops Manager, or more concretely, let me redirect you and remind you there was a really good presentation from our product manager, Chris Shelmerdine, on the first day of Nodes about Ops Manager that I really recommend you watching. He even showed some things that haven't been released yet, so that's interesting. Just to give a short summary, Ops Manager is a new tool for administrators that can help you observe the state, the health of your Neo4j deployment by looking at metrics, for example, or it can do things like give you an upgrade path tailor-made for your Neo4j deployment from one Neo4j version to another one. So that's really nice and helpful. Don't want to go into more detail than that. Let's talk more about dogfooding. And dogfooding, as you might know, basically means that to eat your own or to use your own software. And Neo4j produces a lot of that, and the Neo4j ecosystem produces a lot of software. So like Alex already alluded to, we had the goal of using as much as possible to have more feedback loops there, to maybe file the occasional bug or feature request, make our own ecosystems better by doing that. And I can just say, that was a really good experience, and I love doing that. So what do I want to talk about? This is the general architecture of Ops Manager. You can see there's a host instance where your Neo4j is running that you want to monitor and administrate. There's this little NOM agent running on it, a little Go program that sends all the metrics to this NOM server. And that NOM server is also having a little persistence database that is, of course, it is a Neo4j database. And I won't talk about user interface because I'm a backend developer and I know where my limitations are. So let's talk about how to use Neo4j to store metrics. That's the first thing I want to do. And then I also want to talk about how we can take what is inside that persistence and migrate them from between different data models. That's interesting, right? Then there's a tool called Spring Data Neo4j that makes our life in the NOM server so much easier. And to make it even easier to use Spring Data Neo4j, we also use the Cypher-DSL. That is a still pretty hidden gem. So let's talk about those four things now, starting with how to store or using Neo4j to store metrics. And in the beginning, they said to us, well, Neo4j isn't optimized to store metric data. It's not really a graph, right? And they're right. But we said, well, let's see how far we can take that. Challenge accepted, right? So as you can see here, we have nodes, and they're not really related at all. Every node is like 1 point for a specific specific value at a specific time. Not related, not really graphy. Let's look at the nodes. Let's look at the first data model that we came up with. You can see here in this little JSON representation that we have labels. Cool. So it's a metric label on all of them, makes sense. There's an additional label telling you what kind of metric that is. So it's a histogram or Gaussian metric or whatever. And then there are certain properties. Which NOM agent is that thing coming from? Which instant was that on? Obviously the name, the value, additional labels, the timestamp, really important. Pretty solid thing you would come up as a first level data model, right? You can see some of them are a bit repetitive. If you scale it up to like millions of nodes, you will have loads of nodes with like the same instance ID, right? Might be something you can optimize there. The real problem is obviously this grows indefinitely. So just pumping out new metrics like this means that, yeah, you will run out of storage space at some point. So you have to optimize for that a bit. And you have to just clean up old metric data at some point or roll them into aggregated ones. So we thought maybe we can improve this. And we did. We just recently worked on improving this. We still have one data point, one node per data point, but you can see now we changed around the labels and properties. The timestamp is now an integer, which doesn't look like it saves much. It actually does, and you scale it up to millions of nodes. But the most interesting thing is obviously that we now use agent and name inside the labels instead of properties. Why do we do that? Well, if we have the name property, the name as a property on every node, we have one property record on every node. If we instead use a label, we can just have a little reference on that node. It's probably an integer or something like that. Instead of that string property, which is really, really much more tiny. So we actually save just by having this label reference here on that node, on the node. And we also get rid of a few things. For example, if you see here, there's this label thing. It's basically empty. Why save it, right? And doing all of those things netted us, well, over half, an improvement of basically half the storage size. So that's pretty neat, right? So you can see you can store metrics in Neo4j. Pretty cool. But damn, I just now fundamentally changed the data model. So I need to write a program for the next time that will start, that will knows how the old model works and translate that into the new model. No, I don't have to do that because I use Neo4j migrations, which our colleague Michael Simmons already gave a really good talk about. So I don't want to repeat that. I just want to give you some examples here. But you can do schema migrations and refactoring super, super easy. And there's a module for Spring Boot, which handily fits into our architecture. So let's just have some examples. And the first one, a Cipher-based migration. You put in some Cipher scripts, you execute them. It's done. You can do some index changes, so set up schema. You can actually set up data as well, which is super helpful if you do tests. You can pre-populate your test databases with that, for example. Really, really great. There are catalog-based migrations, which is basically you can set up schema without the need to remember all the Cipher syntax. Really handy. And there's something I really, really love. There are certain refactorings in there that are for you to take. And this one is my personal favorite because it actually creates the new form of database indexes that come with Neo4j 5 automatically for you. So if you haven't done that yet on your Neo4j 4, just running this creates them automatically. And if you then move your Neo4j into to Neo4j 5.1, for example, the migration will automatically kill your old indexes. So just running this once helps you immensely, just migrating your database to Neo4j 5. That's great, right? And then there are Java-based migrations. Just a simple Java class, and through that context, you can just get to the driver running underneath and then do all the things you want to do with that driver. For example, I'm running a call in transactions query here, which I actually can't do on the other Cipher-based and catalog-based migrations yet, because as of today, Michael sent me a link of a commit where he made also that possible. So there's a tight feedback loop going on here, and I thank you a lot, Michael. Let's talk about Spring Data Neo4j. So we're on the server now, and we obviously need some kind of graph to object mapping, right? why should we build that ourselves? So what we do, we use Spring Data Neo4j or SDN, and it gives us reactive programming. There's a really, really nice Spring Boot integration, and I will stress this one, there are no surprises. It's really what you expect. You have a Java class representing a metric, and you just have this annotation, which will translate to a label. You have some internal ID. I don't care about that. I don't need to care about that. And then I just fill in some properties. And when I want to create one of those, well, there's this reactive Neo4j template. I can just create this metric like I would any other Java object and save that to the template, and I'm good to go. And the same way, I can just retrieve it. I can take the template, say find by ID, and get that very data point back. Obviously, you don't want to do that with metrics ask for like a certain ID, right? So you can also have repositories and run Cypher queries on them, and then put them into specified methods. You don't have to read all of that, but you can just do that. You can also do that, just run Cypher queries on the reactive Neo4j template as well, if you like. But to run Cypher queries, you saw that was a string. And strings, Cypher and strings, yeah, sure, I can do that. But if I generate those things, it gets complicated. I need to do string concatenations, and no one wants to do that, and it will fail. And if the syntax changes, that will fail as well. And I need to go in and change strings, and everyone hates that, right? So that is where the Cypher-DSL comes in, because this one uses a builder approach and is actually type safe. So my whole code gets checked at compile time to see if it actually still works, and it only generates valid Cypher constructs. That means that if the syntax changes and I just update the dependency, it will just do the new kind of query. I don't need to go in to change the strings. It's neat, right? So I have an example. We have this query where I just ask for any metrics between a certain start and end time in order by a timestamp, obviously. And this is how it would look like. It looks longer, obviously, but it's still the same thing. You still have the query here where you have the match on a metric, on this metric variable, which is basically just a node with a label metric named M. And I can reference that, for example, in the order by clause by saying, I want to order by this metric timestamp. And then I can have some where clause, which is basically the same thing as the other one. And that's that. I run the same thing on the repository or the reactive Neo4j template, and I'm good to go. And that's the very quick run through some of the tools that we've used, the Dogfooding that we did. Just to recap, data modeling is really, really fun in a graph, even if you don't have relationships. Neo4j can definitely be used to store metrics, even though it's not optimized for it. But if you have good index strategy, right, it's totally possible. Dogfooding itself is like a great source of feedback for finding bugs and making new friends. And the Neo4j ecosystem is really, really rich and really helpful. Like I showed you 3 things. We obviously also use the Neo4j drivers, the Prometheus endpoint in Neo4j itself to monitor the Neo4j deployment. We use Neo4j Aura for hosting our test databases in the cloud. And there's so much more in there that we didn't use yet. And I'm looking forward to using more of those things. Special thanks to Michael Simmons and Garrett, because they produced all of those free wonderful things, tools and frameworks and libraries. And they're really quick when you have like a feature question or like want something improved. And please try them all out, especially Ops Manager, because we love to hear about your experiences. We love to have some feedback from you. So I hope to hear from you, and thank you.
Cool. Thank you very much, Sascha. Chat, you know what to do. I don't have to tell you, I hope. Yes, here we go. I remember now. One question, there's time for one question, I think, from John. How large have you seen the NOM database get number of nodes and size? Do you remember this?
Good question. I haven't seen any customer databases yet, so I can't say how it looks like in the real world. And we're doing a lot of experimentation on how much we can fit in there, what's feasible. So I can't really answer that, because the things we try out is probably more than the real world will see. But if I'm not mistaken, there's some documentation how to spec your NOM server or the database that goes with it. And maybe my colleagues can help me out as well.
Yeah, no worries. Cool. Thank you very much, Sascha, for this presentation.
Wonderful. Thanks, Ava. Hi, yes, so I'm Paul Blewett, and I'm the product manager for Aura DB Enterprise. Thanks for coming along today. For those of you who are completely new to Aura, put simply, Aura is Neo4j's fully managed graph database as a service. Aura DB focuses on transactional use cases from free to pay-as-you-go and up to enterprise mission critical capabilities, which is my world. So I'm really excited to tell you about what the Aura product managers in partnership with our team of brilliant Aura engineers have been up to over the past year. I'll share some of the key deliveries which have brought us to this point, and I'll also give you an indication of what we're focusing on as we finish out 2022. So we've been on quite some journey since we first launched Aura DB Enterprise. I joined the business, when was it? We were in early access in GCP. We were still under lockdown, COVID measures, and doing everything that we could to build a robust product that was mission critical and could support graph use cases in the enterprise. We, like many of you, were also doing this remotely and during uncertain times. But since then, we've moved fast, getting to general availability across 2 clouds, while introducing a range of features to help our customers manage, observe, and operate their database estate more efficiently, and most importantly, more securely. Today, I'm here to tell you about the next milestone in Aura's journey, though, and I'm pleased to announce the early access program for Aura Enterprise, fully managed on Microsoft Azure Cloud. Built on the same battle-tested foundations as Aura DB, and as any existing or new customer should expect, it will be fully automated with zero administration, scalable on demand, has high security and reliability, it's always on, with no downtime, and it has simple, predictable costs. Aura DB Enterprise is built on Kubernetes with common cloud-first architecture, which integrates really well with other Microsoft Azure services, as you'd expect, like Azure Active Directory and Azure Private Link. The Aura architecture splits into 2 distinct parts: the Aura control plane, which allows customers to administer and provision their services, and then the Aura data plane. In Enterprise, each database runs inside a dedicated VPC network for each customer, managed by Neo4j, and the customer's Azure application will connect from their own VNet. All data is encrypted at transit and rest. And as you can see in this diagram, I've used one which has Azure Private Link as part of the architecture. For added security, I'll mention again later, customers can also use their Active Directory federated single sign-on to authenticate to their database. So what do we mean by zero administration in the fully managed Aura Azure world? Well, you can scale up without downtime. We automatically release upgrades and patches without service interruption, so that customers get the newest features and performance. We manage and retain backups for the service for up to 90 days. And we offer the operational features that our users are expecting when running their database estates, such as the ability to pause and resume to save costs, creating a database instance from a snapshot, or cloning it across regions or products, or accessing query and security logs for investigation and audit purposes. Aura Enterprise on Azure gives you performance at scale, and the early access program will offer instances up to 384 gig with native graph engine storage. Multiple databases are available per account within your agreed quotas. We constantly monitor performance and also auto-scale storage and compute across a 3-node cluster on behalf of our customers. And as I said before, we continuously release and improve the service with the best of Neo4j. I'm sure you've already heard a lot about Neo4j 5 so far this nose, so it won't be a shock to hear that it will also be available to all Aura Enterprise Azure early access customers as well. Aura Enterprise on Azure is self-healing and always on. It's highly available with even when scaling or releasing. It's ACID compliant and always backed up with data replicated across 3 nodes. And due to the way it's designed to run in any region with 3 or more availability zones, it also ensures durable failover distribution. Something I've learned a lot about Aura Enterprise customers, as should be expected, is that they care a lot about security, both in terms of their own customer data and in understanding what we as Neo4j Aura use for our own checks and balances. This is why, even at early access stage for Aura Enterprise Azure, we'll be providing this with granular role-based access control to the database, including encryption at transit and rest for storage and backups. It will have VPC isolation with optional Azure private link. It will have single sign-on with Active Directory as standard, although other IDPs following single sign-on out-of-the-box OpenID Connect protocols can also be used. Compliance-wise, we're ISO 27001 compliant, GDPR and CCPA ready, and with SOC 2 Type 1 compliance already at the Aura platform level, we have SOC 2 Type 2 to follow next year, with regular audit cycles to follow, including new products that we're taking to general availability in 2023. Aura Enterprise has UX-driven, industry-leading developer tools built into the platform. Browser offers visual query editing with built-in guides, helping you to get the best of Aura instances when querying via Neo4j's developer language Cipher. Bloom is our visualization, exploration, and collaboration tool. Previously in beta mode, this is now in GA on Aura. And in the enterprise, we are also embarking on an early access program for scene saving and perspective sharing. That program will also be open to select Aura Enterprise on Microsoft Azure Cloud customers. Both Browser and Bloom are also tools which customers can place single sign-on in front of to improve their security posture. We have a suite of connectors which help enterprise users integrate with common architectures. These include Kafka and Spark. We have various language drivers, Python, JavaScript, Java, GraphQL, Spring Boot, .NET Go, which make connecting to your database flexible. These are all official and also supported in the community. And we also have an API in beta right now, providing a programmatic way for customers to provision and manage their Aura estate. This will be something that we'll be looking to talk to our Azure early access customers about too, ahead of 2023. So I know what you're all thinking. This looks amazing. Where can I get me one of those sweet Aura Enterprise on Microsoft Azure deals? Well, it'll be no surprise to hear at EAP, you'll be able to purchase via a private offer in the Azure Marketplace. We offer a consumption-based pricing model where you can prepay for your Aura DB credits and have flexibility to spend those across the duration of your annual subscription. And in terms of subscription, we offer a 1, 2, 3 year option as standard. More on negotiation. I'm sure Kane there, our VP of sales, will be happy to talk to you on the chat or after the session. And 100% of your Aura DB enterprise spend goes to retiring your Azure commitment. So we make it easy to utilize your Azure commitments. And have volume-based discounts on enterprise level usage forecasts too. So My prayers to the demo gods went unanswered today, and coupled with some flaky UK coastal broadband, I won't be flashing up the Aura on Azure journey. However, if you take a look in the Hop-in goodie bag, you'll see our Aura free offer. Please do sign up and give us feedback on the experience. We work really closely at the Aura PM level to keep the SaaS platform experience common, and we take as much learning as possible from the developer-led experience and move that into the enterprise world where we can. But better still, get in touch with cloud sales at neo4j.com to discuss a proof of concept on enterprise. So it wouldn't be a lightning session without leaving you with some key takeaways. Did I mention that we've released Aura DB Enterprise on Microsoft Azure yet? Well, I'm sure I must have done, but we have, and it was today. So what do you need to remember about Aura DB Enterprise on Microsoft Azure? So it's available in all regions, supporting 3 availability zones or more. It's available with RBAC, single sign-on, and private link from kickoff. It supports up to 384 gig clusters, fully managed with 0 downtime and 24/7 support, and available to purchase through Microsoft Azure Marketplace via private offer. Right, that's all from me. I may see you again later for some questions, but in the meantime, thanks for listening to me waffle on, and please enjoy the rest of the show. Thank you.
Thank you very much, Paul. That's an exciting news. Let me see if we have any questions. I don't think I've seen any right now. They may come after, so you may want to check the chat. Otherwise, thank you very much. And for everyone that's still here, we'll be back in a few minutes. Thank you.
Hey everyone, hope you're enjoying Nodes so far. If you didn't know, this week is International Geography Awareness Week, and today specifically is GIS Day, which is Geographic Information Systems. So this is an appropriate topic to dig into on GIS Day. We're going to be talking about working with geospatial data in Neo4j. So my name's Will. I work on the developer relations team at Neo4j. So largely my job is to help developers build applications with graphs and Neo4j. When I should mention, these slides are available, dev.neo4j.com/geo-nodes2022, or you can snap a picture of that QR code. I have my Twitter handle up there and my website where I publish a blog. That's probably the best way to get in touch with me these days. So when I first started learning about GIS, one thing really stood out to me when I learned about what's called Toblers First Law of geography. And this is that everything is related to everything else, but near things are more related than distant things. And this really resonated with me because really this is sort of graph thinking as sort of the foundation of geography and GIS. So let's look at an example. So I was recently in Minneapolis for a trip. So if we were to apply this framework, we could say that San Mateo is where Neo4j headquarters is. So San Mateo is more similar to Santa Cruz, San Francisco, and San Jose than it is to Minneapolis. I mean, Minneapolis is over 1,000 miles from San Mateo. And we can quantify this similarity using physical distance. So for example, yeah, that was close, 1,500 miles from San Mateo to Minneapolis, while the other cities are much closer together. So that's one way to represent these relationships. But Tobler was really talking about not just physical distance, but also things like human geography, right? So I could say these cities maybe are culturally more similar than Minneapolis. Anyway, however we want to represent that, it is talking about geography as a graph. So this really stuck with me because graph data structures are really fundamental to working with GIS. So a graph fundamentally is this data structure. Nodes are the entities, relationships connect nodes. And in order to work with data in a graph, we add properties. So we can store properties in arbitrary key value pairs on nodes and relationships. We add labels as a way to group nodes. Every relationship has a single type. This is the property graph data model. Now, once we have an instance of a property graph, then this becomes a knowledge graph. So a knowledge graph is talked about in lots of different ways, but the way I think of a knowledge graph is really just an instance of a property graph. So I have some data modeled with the property graph model that puts things in context. And things is an important concept here, even though it sounds simple. But once something is a thing, that means that I have a canonical representation of it in the graph. So this example, this is data from New York Times articles. New York Times has an API. So we've loaded some data about articles, about people mentioned in the articles, the geo region. So I have a canonical representation of these things now. So when I have a new article about US politics and government, I know that I need to attach that to the US politics and government topic node. And that helps me contextualize the data that I'm working with. So this data, like I said, comes from the New York Times API. I have a little service set up to fetch the most popular articles every day and load that into a Neo4j Aura database. So we'll take a look at that in a minute here. But once we have that data in Neo4j, there are a few ways that we can analyze it, that we can work with it to build applications. I think this is kind of a spectrum between our graph local operations and our graph global operations, where local traversals are I'm traversing the graph from a well-known starting point to answer questions like what are the news in my area today, to things like let's analyze the most influential people mentioned in the news. That's going to be something like PageRank with a graph global operation. And we'll see today how everything along the spectrum can be relevant for working with geospatial data. But first, let's back up and talk about some of the functionality in Cipher for working with spatial data. So Cipher supports a 2D or 3D point type with either a geographic or Cartesian coordinate reference system. So when we say geographic coordinate reference system, we're talking about latitude and longitude. And with the Cartesian coordinate reference system, that's sort of a bring your own domain. So if we're working with geospatial data, we're probably going to want to use the geographic points. If we're working with something on an XY or XYZ plane that doesn't necessarily map to location on the surface of the Earth, I've seen examples of things like modeling a manufacturing process or modeling some sort of in-game VR type scenario. That might be a good case for working in the Cartesian CRS. So the units for latitude and longitude, these are decimal degrees. The units in Cartesian, well, they're whatever I want them to be, whatever the domain I'm working with is. Because we're talking about geospatial data today, mostly we're going to limit ourselves to looking at 2D geographic points. So here's just an example in Cipher. I can use this point function to create a point instant. And once I've created that instance of a point, I can store it as a property on nodes, on relationships. So here I've created a point of interest node to represent some bakery somewhere. I think this is actually somewhere in Germany, and set the location property to this point value. Once I have points, there are a few other sort of base spatial functions in Cipher that are relevant here. So point.distance, which will compute the distance between 2 points, point.within bbox. This is useful for searching within a bounding box, so searching within a rectangle to find other points. And then the point function, which we've already seen for creating point instance. So here we are searching for point of interest nodes where the distance between the location property on our point of interest node and some arbitrary point that we've defined is less than 200 meters. And I find a couple of bakeries and a kindergarten. Okay, so let's go back now to our New York Times news graph data. So we have data about articles. We know the topics of the articles, if they mention an organization, a geo-region, and so on. And I should mention, when we fetch this data from the New York Times API, it does pull out geo-regions, but it doesn't give us latitude and longitude. We'll just get something like London or the White House, Washington, D.C., or something like that. And so what we can do is geocode those location descriptions and turn that into latitude and longitude, so we can create points so we actually know where these georegions are physically. That's the process of geocoding. Geocoding is available in APOC. If you're familiar with APOC, APOC is kind of the standard library for Neo4j, adds lots of additional functionality to Cipher. So there's an APOC spatial geocode function that will, by default, I think it uses the Nominatum OpenStreetMap geocoding service, so kind of low bandwidth, but we can also configure it to use Google's geocoding service, which is what I typically use. But anyway, you can see we give it some sort of description of a location, and then we get back a latitude, longitude, and description of this. And this is exactly what I use in the little service I have set up to pull in this New York Times data. You can see here. Well, actually, let's just look at the code. This is on GitHub. So this is a GitHub action that I use to basically set a cron job to, I think once a day it runs. There's a GitHub action called flat, which allows us to basically go out to a JSON endpoint or run a database query and then work with that data. I wrote a little extension to that called flat graph, which allows us to just define a Cipher query for how we want that data to be added to Neo4j, and it points at a Neo4j Aura instance. And then after it fetches the data from the New York Times API, I just run this query. So any geo-regions that don't have a location, we try to geocode them, and then we set the location to the result of that geocoding process. Okay, so once we have that, we can then write queries that say things like, show me the news for the day closest to me. So this query, this is saying find georegions where the location is less than 200 kilometers from this point. This is somewhere in Montana. So we have to go out quite a bit before we find things within 200 kilometers. And we can find some examples. So here's an article about this famous Chinese food restaurant in Butte. We have some other articles about things that happen in Cascade County, which is a county in Montana. We can see the topics of those. So we can traverse the graph once we have the starting point of our geo region. We can also do some simple pathfinding operations. So pathfinding doesn't necessarily need to be specific to geospatial data. Here we're finding the shortest path through the graph connecting the Federal Aviation Administration to the National Park Service. And it turns out there was an article written about each that both are connected to this topic, national parks, monuments, and sea. So it ends up being a fairly short path. Now, Neo4j is a database, which means that I often want to be able to work with Neo4j and other tooling to accomplish whatever task I'm trying to do. And it's really important that these integrations and this tooling work together. So let's say that I want to create a map that is showing areas mentioned in the news. Here's a map that does that. We've put a dot everywhere that has a geo area mentioned in a news article in the New York Times. We could improve that a little bit. One thing we could do to improve it would be to make those dots proportionally sized to the importance or the relevance, or maybe how many articles are written about that georegion, that would be a good place to start. Maybe run PageRank, something like that, some centrality measure. And this map, this is a screenshot from QGIS or QGIS. Let's take a look at how we created this. So here's QGIS. QGIS, if you're not familiar, is like a desktop GIS tool. So we can use it to analyze GIS and spatial data. And let's see how we can create this sort of map where we are showing all the regions where some news has been mentioned, and we want to draw that proportionally to the centrality of that georegion. So starting off, we have a lovely Robinson projection of the world, which allows us to see the world in one view, and then some natural earth shaded relief. And then down here, we have the Python console. So we can use Python to interact with QGIS, and that's exactly what we're going to do. So I have a Neo4j instance, news.graph.zone. This is a read-only user, so it's fine that we're sharing our credentials in this case. You can log into this database and query the news if you like. Then we're creating a new vector layer in QGIS. We're doing some setup for proportional symbol size to render our symbols. And then here's our Cipher query. So we're matching all georegions, and then we're calculating just centrality, degree centrality of that georegion. So basically just how many articles were written about that georegion. And then we have some functions here for once we run the query, how do we create a point and add it to our layer in QGIS. So we'll give that a run. Let's zoom in a little bit. So we can see, okay, we have a bunch of dots that represent different places that are mentioned in the news. Areas that have more news articles are slightly larger. We have that proportional symbology there. That's useful. So now let's look at relationships between these georegions. So I'm going to run another Python script, and we're doing something similar. We're setting up some proportional symbology. But now here's our Cipher query. We're going to look at geo-co-occurrence. So for a given article, what georegions are mentioned together frequently? We're going to calculate that for each pair of georegions, and then we're going to draw a line connecting these pairs of georegions to see what regions are mentioned together, and we're going to make the thickness of that line proportional to the number of sort of overlapping articles. So we can see some strength in the relationship between these georegions. Okay, so that was a quick look at how we can pull data into QGIS and analyze it using the Python API for QGIS. I've been looking at building a QGIS plugin for Neo4j. So far, there's not much code there, but you can find the Python scripts that we just ran on this GitHub repo also. If you think that would be something useful, drop a note in the issues or something, and we'll see how that progresses. Okay, so let's talk about spatial search with Neo4j. So we know we can traverse the graph using Cipher and Neo4j to answer questions like, show me, I don't know, Irish pubs near me that are open now, that my friend has reviewed positively, that's also around the corner from an Italian restaurant that serves tiramisu because I like tiramisu for dessert, right? We can write those kinds of queries in Cipher, but the spatial search component is kind of the starting point for those types of queries. So I want to find something near me, I want to find something in this certain neighborhood, and so on. So spatial search is important in this case for finding sort of the starting point for some of those traversals. So we're going to look at three types of spatial search with Neo4j. We're going to look at radius distance search. So that's basically find things near me within some radius distance of a point. Find something within a bounding box, within a rectangle. And then the third one we'll look at is point in polygon. So this is useful often for, I don't know, maybe like finding something in a neighborhood where the boundaries of a neighborhood or a census district or something like that. You can find the code in this GitHub repo that's linked down here. So I wanted to use some real world data and a more sizable data set than just the few thousand geo-regions that are mentioned in the New York Times articles. So I wanted to pull in some data from OpenStreetMap. OpenStreetMap is super useful. It's crowdsourced data throughout the world. There's amazing amounts of data in OpenStreetMap, but it can be sometimes a little bit difficult to work with. There isn't a sort of schema or standard structure imposed on some of the tags, for example, that are uploaded. So I like to use the daylight distribution of OpenStreetMap, and specifically the daylight Earth table. This is a distribution that's cleaned up and then published by Facebook, and they impose a sort of 3-tier ontology for OpenStreetMap this way. So theme, class, and subclass is how they define it. So we can search for things like buildings, land, points of interest, and points of interest is what I chose to start with here. And within point of interest, we have things like amenities, and then the narrowest level, we have things like a bench. So I know that this this point has a bench. The Daylight Earth table is available on S3 in Parquet files. So we'll take a look at this Python notebook that I used to import this data. So here's the data model that I came up with here. So we store the point geometry, and in this case, the geometry is just a point. We'll talk about working with lines and polygons in a second. And then we have the point of interest node connected to the geometry node. And I chose to save the class and subclass, or the category and subcategory, as node labels. We could do those as properties. I'm not in love with that model. And then we also have all of the arbitrary key value tags that are also available. I chose to model those on a separate node. So to load this data, I use pandas. So pandas can read Parquet files directly from S3, and then we get a data frame to work with. And then I did a little bit of cleanup. I filtered out any points that didn't have a name. I grabbed the local name, and then we convert the WKT, which is well-known text, which is a way of representing geometries. In this case, converted that to just an array of latitude, longitude pairs to make that easier to work with. And we ended up with, so we started with 30, let's see, will this tell me here? Yeah, we started out with 38 million rows, and then I think we ended up with somewhere around 16 or 18 million after filtering out any that weren't named. Then to load these into Neo4j, we wrote a little wrapper around the Neo4j Python driver. And then it's important to be able to handle these in batches. I don't want to just send 18 million rows to try to write to Neo4j all in one transaction without trying to batch these. So we batched them. I did it in batches of 10,000 rows. We could probably up that to at least 100,000. This just took a few minutes to load on my laptop. Then what we do is use the unwind functionality in Cipher to be able to iterate over each row in the data frame that we end up passing. And then we can just use Cipher to define how we want to create that data in the graph. Okay, so the next thing we did once we've loaded this data is to create a point index. So earlier today, Stu was talking about the new indexing functionality in Neo4j 5. So the create point index, that's new, new syntax, new functionality for new indexes that are available in Neo4j 5. The point index is one of those. So specifically, it uses a Hilbert space filling curve over a generalized B+ tree. You can read more about the index and what that means in that link there. But the nice thing about this is we don't have to understand how the index works to be able to take advantage of it. It takes just a couple of minutes to populate the index. So you can, when you create the index, you can either have that block while the index is being populated, or just kind of check back. If you run schema in Neo4j browser, you can see the status of your indexes. Okay, so why are indexes important? Well, we have like 18 million or so points of interest, which is, it's not an enormous data set, but it'll make a sizable difference as we're searching things. So on the left is the same query without using an index, where we end up doing a label scan, and we end up spending just under 4 seconds to find our points of interest, versus on the right, we do a node index seek, which is much faster. That results in just 200 database hits in anywhere between 1 and 3 milliseconds it seems to take on my machine. You'll notice it still does a filter after the index lookup, and that's because the index gives us basically points within a bounding box, and then we need to do a filter to filter the sort of circular radius, since we're doing radius search here. Okay, and I wrote a little demo app. Let's see if this will work to try to showcase how this works. So this is a leaflet map, just a simple web map. I've pulled in a leaflet plugin that allows to draw on the map, and then the Neo4j JavaScript driver. And so there's a few different ways we can search here. So one is I can draw a circle. So we'll go up here to Millbrae near the airport, and we'll search for points of interest. Okay, here's some points of interest near the airport. And the way this works, so here in our event listener section in our JavaScript code, it's the case where we drew a circle. We grab the radius and the center point of the circle, and then our Cipher query is looking for points where the distance from the center of the radius is less than whatever the radius is that we drew. And then when we get those results, we just create a marker and add those to the map. And you can see that's pretty fast. And we're searching a database on my machine with 18 million or so points of interest. So we could do this anywhere in the world, but let's just go down now to Burlingame. And this is now the bounding box. And so in the case where we drew a rectangle, we're going to do this point.within bbox query. And in this case, we pass the coordinate for the lower left, so this one here, and then the other argument is the upper right, and that defines the bounding box. And then we get back all the points, and then we search for additional information like the tags, the name, and so on. Okay, and the final one that we're going to do here is polygon, so point and polygon. So this is useful. You see this a lot on real estate sites. If I want to search within a certain neighborhood, maybe I want to be within, I have no idea what this neighborhood is in San Mateo, somewhere between Foster City and San Mateo. Now we can see here are the points just within that polygon. And point and polygon ends up being a little bit more complex. What we do is when we get the polygon geometry, the first thing we do is convert that to a bounding box. Then we can do a within bounding box query in Neo4j, which will use the index. And then once we have that, then we filter on the client to remove any points that are within the bounding box, but not within the polygon. And the reason we do that is we want to be able to take advantage of the index in the database for that really fast search. Okay, and these are just some screenshots of what we just saw in the demo app. Cool, so far we've been talking about point geometries. How do we work with things like lines and polygons? Well, one way to do that is to store arrays of points as properties on nodes or relationships. So here's an example. I exported all my data from Strava and added that into the graph. And here you can see I'm storing the point in an array called coordinates on the node. And we can do line search very similarly. So let's do a radius distance in San Mateo. And we can see here, we find just one. So this was a jog or something that I went on out to Coyote Point and back. And the way this works, if we take a look at the code, here's the Cipher query. We use the any list predicate to find where any of the points in this coordinates array are within the radius distance that we're searching for. And we can see several of them are, even though the entire line is not. So that's how we can work with line geometries. Let's talk about routing next. So we were talking about this idea of graph algorithms. If you're familiar with the Graph Data Science library, this is a plugin for Neo4j that adds lots of additional functionality. You can see some of the algorithms that are supported, but pathfinding is one class of algorithms that are available in the Graph Data Science plugin. So these are algorithms like A* or Dijkstra, breadth first search, depth first search, these sorts of things. So for this one, we're going to use a data set that is available on Neo4j Sandbox. If you look for, I think it's just called the Graph Data Science use case, you can find this in Neo4j Sandbox. And we have data about airports and airports that have flight routes between them and where in the world airports are located, this sort of thing. So to do any sort of graph algorithm stuff with the Graph Data Science library, the first thing we need to do is create a projected graph. So oftentimes the algorithms that we're running, we're not actually interested in running on either the data that we actually have stored in the database. Maybe we want to infer some graph from what we've stored in the database, or maybe we're interested in just a subgraph. But either way, we need to project that graph from the database into memory so we can run these algorithms. And in this case, we're interested in a weighted relationship where distance is the weight. So distance between two airports. And let's take a look at this example. So these are not all the airports of the world. I filtered for, I think, airports that have at least 2 runways or something like that. The marker size is a little busy in this case. So let's say we want to go from Punta Arenas in Patagonia to Honolulu. Here's the shortest route by distance is to fly to Santiago. And I think we actually have a stop in Easter Island here. And then we fly to Tahiti and then up to Honolulu. So this is using Dijkstra's algorithm, which is a weighted shortest path, similar to A*. With A*, though, we have a function that's telling us how close we are. Of course, this is a fairly simple airport routing logic. We can do lots of other things to factor in as well, like cost and time, connections, these sorts of things. Okay, so I have just a couple minutes left, and I have one more example that I want to talk about to showcase one of what I think is the most powerful features of graph databases like Neo4j, and that's the ability to combine data sets and query across them. And so for this one, I was looking at a database of protected areas in the US. So the US Geological Survey publishes this protected areas database. And these can be things like national parks, wildlife refuge, these sorts of things. And then I wanted to take a look at US Congress to see, well, how are these protected areas being legislated? Are there bills in Congress that are doing things like maybe trying to change the size, adjust the funding of some of these, kind of what's going in Congress related to these protected parcels. And so to do this, I use the ProPublica API. Once I've loaded in the parcels, and I'll look just briefly at how we load the parcels. So the protected areas database, this comes in the format, I think, of a bunch of shape files, perhaps, but I use the GDAL command line tool to reproject and convert these to GeoJSON, and then we can use the APOC load JSON functionality to load these GeoJSON files. And the thing I want to talk about here, though, is these are polygon geometries, right? So a national park, a protected area, is some polygon geometry, and to represent that in the database, I store these again as a array of points to represent that polygon geometry. So once we have that, we can do things like in Neo4j Bloom. Oh, we disconnected. That's okay. Let's switch back here to QGIS, because I have one more script we can look at in QGIS, which is to load these polygons. So we'll run that. And what this is going to do is go out to this Neo4j Aura instance where I've stored this data and draw these polygons. I pulled in just one region. So we have things, this I think is Glacier National Park. And I have that information available in QGIS. Now, what's really powerful would be to combine the visualization, graph visualization functionality that we have in tools like Neo4j Bloom that allow us to see this parcel in the context of how it's being treated in Congress, what legislators are involved with Glacier National Park, what other protected areas are they involved in. These sorts of things help us put that into context alongside our GIS data. Cool. So I think we're about out of time. I'll leave with just a couple of resources to mention if you're interested in learning more, working with geospatial data in Neo4j. The first I'll mention is Neo4j Aura. Neo4j Aura is Neo4j's hosted cloud service. It has a free tier, so I can spin up Neo4j and have a free instance that's always around, which is great for loading data, building these types of little applications as we're learning. Neo4j Sandbox has more example data sets and guides. So for example, the graph data science airports data set, there's also a data set specific to OpenStreetMap that includes graph data science and some of the routing functionality that we mentioned. Cool. Well, that's all I have today. These slides are available, dev.neo4j.com, geo-nodes 2022. And I'll jump into the chat and see if we have any questions.